In today's lecture, we actually didn't get time to look into this periodic review model, or this is simplest periodic inventory review model. So different from the SQ system. SQ system is a continuous review. So here RS is a typical periodic review. So we start this lecture only with the simplest inventory systems. So RS is actually the simplest periodic review system. If we do kind of a transformation, we can see actually RS model is similar or somehow equivalent with the small s and a Q model. So in the SQ model, we decide the reorder point, order quantity, and based on the lead time. And in the RS model, we actually need to decide the order up to level, and we know the demand distribution over the review period plus lead time period. And your average or expected order quantity actually is your demand times your review period. So here the capital D is annual demand, then the R should be the same unit for years. So if your review period is 3 months, then the R should be 0.25 years. Then that means D times R should be less than the total annual demand, capital D. So here capital R actually is a decision variable as well. So we actually need to make decision about review intervals. So that's actually easy to be determined by the company. They review their demand for every month or every week or every 3 months. So here the question is, if they need to order by the review interval capital R, then this R actually is a very important decision variable. If you have other threshold values for reorder decisions, then this R actually is not that critical. Currently in this model, R actually is very important because the length of your review period will determine how many units you actually need to order. And then we also have these decision variables about order up to level, capital S. So the order up to level, the key time period over which protection now is review period plus lead time. We can actually further explain that later in the graph or in the table illustration. Continue with the last slide. We know the key time period in the periodic model actually is the time, the duration of a review period R plus your lead time. So we continue with this analysis. So order up to level at T0 must be sufficient to cover the demand through the R. So here this is the R, and here we have the period of L. So you should be able to cover the demand over R plus L time. So any stock outs up to time T0 plus L actually will not be influenced by your current ordering decision at the time T0, but this decision will definitely influence your likelihood of stock out in the far end of the time T0 plus R plus L. So if I change a red color, so you can see this time point will actually affect the stock positions were actually affected by your decision at the time 0. So that's why we needed to look into this entire period. So here is one illustration of why R plus L is crucial time in order to decide the order up to level. So here we can see at the time T0, actually there is order. So there is order, this order. So we can see furthermore this order update your inventory position at T0 time, and then in the following period you can see first there is a demand in the first lead time period, and then until the next reorder period we have a new order quantity or demand, and then we also have the third demand for the second lead time. So you actually ordered in the time t plus r. However, this order will not arrive at the end of the t0 plus r plus l. So that means we can see the E value, so it's the net stock at the end of r plus l time, actually determined by your initial inventory position at T0, and then the demand will be B, C, D, 3 different demands. So in that sense, stock situations in end of R plus L actually should be the focus to evaluate the possibility for the stock out. In that sense, R plus L is a critical period, should pay attention to. Now we actually try to formulate this problem or find a solution. So first, we ignore the costs. However, if you're interested in the cost performance for this system, suggest to look into page 281 in the textbook. Now you can see it's possible to evaluate the on-hand inventory levels, which is S, order up to level minus your expected demand in the period R plus L, and then expected order quantity, half of the expected order quantity. And then we also know the expected shortage. So expected shortage per replenished cycle. So similar with the small SQ model, then we actually have a standard deviation over this critical time times a G function, so the standard loss function. So that's the expected loss. And your order times actually is your, if you know this is 1 year, and each review period is R, then that is your order frequencies. So that's if you know the unit cost for inventory, for shortage, and for ordering, then you can actually evaluate the costs. We do not repeat what we have done with the small s and a Q model. So here we focus on the service level as the decision objectives. So here we know the normal demand distribution over the review period plus lead time. So if it's a service level, we're actually talking about if you have the demand distribution for the R plus L period, which is a normal distribution, then we try to actually decide an order quantity which makes sure your demand actually is less than your order quantity. This actually is a service level. So the key of the order safety factor of key is actually determined by the value of your targeted order quantity plus the average demand over your critical time divided by your standard deviation. So if you have to translate the safety factor, the meaning of safety factor, then you know actually the key is related. Always the order quantity actually equals to average demand plus key times sigma. R plus L. Then here in this problem, where order quantity is order up to level, that's actually S. I actually already tried to explain what's the average on-hand inventory and the shortage. So here we actually also know the probability of stock out in the replenishment in a single replenishment cycle is actually the normal distribution. All we see is the probability of the demand in this period greater than or equals or greater than your order up to level, which is our new P function. So the on-hand inventory is given here. You can see this approximate value because the DR is the expected value. The real order quantity actually is capital S minus your inventory levels at the review period R. So this actually is uneven value. It's not the constant value. And then order up to level, capital S equals to safety stock plus average demand or mean demand for this critical period. Then we can calculate safety stock. Then if you replace the critical period by R plus L, so that actually we fit to the same model for S and Q. So hopefully you can make a connection between these two models. This is a numerical example based on the capital R and S model. So again, I repeat, this is a periodic model. And then we know we have a targeted service level. So assume that the targeted service level is 95%. We claim this is P1, not P2. And in the Excel, we did a calculation. This problem actually is simplified because we do not have any cost information. We only focus on the demand distributions, and then we determine the safety factor, key star, or optimal or the best targeted safety stock. Safety factor key, we got this value 1.65, and then we translate this key value into safety stock and order up to level. So if we have to re-explain why we have this key value, then we can actually see your S order up to level is the order quantity you supposed to cover the demand for the period R plus L plus your standard deviation of your L. So this key value determines how much security you would like to have regarding your stock out. So that's also why we directly can translate your safety stock is key times sigma R plus L. So again, once you find a key, then you find all the other order quantities. In this problem, our R review interval is given. So we do a sequential optimization. If you ask then what is the best review interval or the reorder period, then I would suggest you to try to see the different R values and see if they will give you better cost structure. So you can look into cost structure regarding different R values. So for example, here we have R equals to 3 months, then you can try what is when the R equals to 1, 2, 4, or the other order periods. Of course, we do not have costs given in this example. You can use some assumptions or our previous examples costs to look into this problem. That's very important. You can integrate both cost, performance, and the targeted service. Then you know how your decision will lead to the performance. So here we have a quick summary. We actually mentioned how to select different order policies. That's also actually the purpose of teaching stock management in this course. So we are talking about what is appropriate inventory systems or models for your product in your company. We only look into the deterministic lead time, and we assume the fast moving items. So we use a normal distribution, and then we look into a single item, and we determine when to order and what's the order quantity. And then we also look into how to evaluate the performance of your order policy, including both the cost performance and customer service levels. Service levels including P1, P2. So you have to understand what's the difference between P1 and P2. And then we have mainly two types of strategies, continuous or periodic. And then if you do ABC analysis for A terms, A items, so we call it important items. So that is a rule of thumb. So if it's important items, so you choose to do small s, capital S, or R, small s, capital S model. For the B items, which are our focus today. Then we're talking about to use SQ and RS model. So next lecture we will talking about A items. So you see more different systems or the inventory models.